Okay, so we did introduction to functions yesterday. Today we'll actually do a good few examples actually, because it's a bit newer now today. This is when composition of functions, meaning we're substituting functions into functions. I think there was a question, and I think Mohammed asked, where there was one in the maths tables where I was saying, or not the maths tables, the maths exam papers, G, O, X, this little symbol. That means the G of F, or simply GF. The GF of X is the way it's written. And it means you put a number through into a function, or put a value into a function, and put then that value through another function. Okay, so it's just the way it's written is a bit more difficult. You're pretty much putting a number into a function and then your answer into a different function. And when it's numbers is okay, but then they obviously include algebra as well. So in general, if f, g are two functions, then the fg of x does not equal the gf of x. So the one closest the x is the one we do first. So it's the g. If there was a number there, you'd substitute into the g first, and your answer you'd substitute into the f. And in this case, if there was a number there, you'd substitute into the f first and then into the g. And they will not be the same. The composition of functions generally is not commutative, means it's not the same forwards or backwards. Generally, of course, there'll be exceptions, but it's not the same. Alright, so what we're going to do is there's 4 examples on the first page. Actually, there's 5. And then there's 6 examples on the second page. So there's quite a lot here, but we'll go through them and then get to try some questions. And if you have any questions, again, just ask. Alright, so the first 5, I've actually only done 4 here, so at the end I'll just pause it. So, it gives you 2 functions, and it asks you to find the fg of 2. And again, that might have been written as FO fog 2, okay, a smaller little circle there, not a dot, a little circle, but it's not, it's written like that. They mean exactly the same thing. So I shrub that. So the fg of 2 means substitute 2 into the g function first. So the g of 2 is equal to 2 squared minus 1, which is 4, minus 1, which is 3. And then we substitute that 3 into the f function, so we're finding the f of 3 equals 3 plus 3 is 6. So the final answer is 6. I've substituted my 2 into my g and my answer into my f. This time we're going to find the f of minus 1. So the f of minus 1 is equal to minus 1 plus 3 is 2. And my answer I'm going to substitute into my g. So now it's the g of 2 we're going to find, and it's 2 squared minus 1, which is 3. They're as simple as it gets. Again, substituting a number in and then substituting your answer into another one. Here, look, we're going to ask to find the fg of x and the gf of x. And we'll show you that they're different. So this time, if you substitute x into g of x, it's just that. So we're going to substitute our g of x, our whole g of x, into our f of x. So that is equal to, so f of x is equal to, I'll just write this down, x plus 3. But instead of the x, the f of g of x, I'm going to substitute the g of x, my whole function, into my f. So instead of an x, I'm going to put x squared minus 1. I'll just put that in brackets just to show you. Instead of the x, I put in my x function. And I just simplify that, and I get x squared minus 1 plus 3 is plus 2. X squared plus 2. And if you look the other way, gf of x, this time my g of x is just equal to x squared minus 1. But instead of an x, I'm going to substitute in my f of x. So gf of x, I'm going to substitute my f of x function into my g function. So instead of an x, I'm going to put in x plus 3. So it's x plus 3 squared minus 1. And I'd multiply that out. I'd get x squared plus 6x plus 9 minus 1. And that equals x squared plus 6x plus 8. Alright. And then it does say something at the end of that section which I didn't spot, so just bear with me. It says, as the last little part of that, it says, find also the values of x. So pretty much solve. So you can see, first of all, you can see they're not the same. Okay? But then it says, pretty much solve fg of x equals the g f of x. So we've already worked those both out. So pretty much let your left hand side, x squared plus 2, equal your right hand side, which is x squared plus 6x plus 8. The x squareds will cancel out nicely. So you end up with 6x on this side. Bring the 8 across, becomes minus 8. So 2 minus 8 is minus 6. So x is equal to minus 1. That's if you're asked. If you're asked to let the two functions and solve it, so x is equal to minus 1. So that's the first round of examples. So take those down. I'm just going to pause it and get the other ones ready. Okay. New function. So this is the example on page, what page are we on? On page 240. So it gives you three functions, f of x, g of x, and h of x. And it asks you to do 6 things. We've got the first 4 here. So the gf of x, that means, so our g of x, okay, just hold on, I'll get a new black marker. The g of x is equal to 1 over x. So instead of an x, I'm going to substitute in my f. So the gf of x is equal to 1, and instead of an x, I'm going to put in my f function, which is 2x plus 1. And that's that one done. Unless they ask you to write it in a different form, that's substituted in. Second one, the f squared of x means pretty much the f of x. Substitute your f of x function into your f function. So instead of an x, I'm going to put in 2. So this is my f of x, just writing it down, 2x plus 1. But instead of an x, I'm going to put in f of x. So instead of that x, I'm actually going to put in 2x plus 1. So 2 times 2x plus 1, and then we have our plus 1 at the end. So all I've done is replace this x with another f function, and you expand that, you get 4x plus 2 plus 1, 4x plus 3. gh of x. So obviously my g of x, again I'm just writing this first line you don't necessarily have to write down, I'm just writing it down just to show you so we're not constantly looking up here. And now I'm going to do gh of x. You could nearly do this straight away. So I'm substituting my h of x into, again, my x. So it's 1 over x squared minus 4. And that's all they want there. The h squared of x is, again, the h of x. It explains that just in between, just before example 1. So my h of x, again, you don't necessarily have to write this, is just x squared minus 4. But instead of my x now, I'm going to substitute in x squared minus 4. So my h of x is, instead of an x, I'm going to put x squared minus 4. So that's all to be squared. And then my minus 4 is there. And we just expand that bracket, and we end up with x to the power 4 minus 8x squared plus 16 minus 4, and we simplify that to x4 minus 8x squared plus 12. Okay, so that's the first 4. Here I think is the question that, or I think it was a question similar to this that came up in the exam papers that I was asked earlier on in lockdown. So it's asking for the hg of x. So what you're doing is you're substituting the g into the f, and then when you simplify that, you're going to substitute into the h. Okay, so what we want to do is start off with the f of x, because this is what we're going to substitute. The f of x is equal to 2x plus 1. Now instead of an x, the f of g of x, I'm going to substitute my g of x into this. So f g of x, I think we'd worked this out earlier, had we? No, we hadn't. We hadn't. So instead of that, I'm going to put 1 over x. That's what g of x is, plus 1. And that simplifies down to 2 over x plus 1. And just for simplicity's sake, I'm going to put it as a single fraction. So we end up with 2 plus x over x. I just multiplied this up here. Okay, put them both over the same fraction. That's simplified, alright. Then I want to substitute this. So this is my fg of x. I want to substitute this into my h function. So my h of x function is equal to, going back to the original, is x squared minus 4. And instead of an x squared, I'm going to put in 2 plus x. So the h of the f of g of x, we already worked this out, so it's this 2x. So instead of an x squared, I'm going to put 2 plus x over x. That's going to be squared minus 4. Multiply that out, we end up with 4 plus 4x plus x squared all over x squared minus 4. And again, then they put that all as over one fraction. That's where they're getting that. So they put it all over x squared. So if this is a 1, we've got to multiply that by x squared. So we end up with 4 plus 4x plus x squared minus 4x squared. Because this would have to get multiplied by x squared. And they simplify that. We end up with minus 3x squared plus 4x plus 4 all over x squared. And they actually, just to show you, they simplify it down. They say x squared divides into that, so they end up with minus 3. X goes into that, they end up with plus 4 over x and plus 4 over x squared. They just split it up into 3 separate fractions. And they have it written like that, just the opposite way around. So just in case you were wondering where they got that. So it's not that complicated, but you can see it's best to make it one fraction when you're substituting it into other functions. And the last one says solve or find the values. Pretty much they're saying solve gh of x is equal to 1 over 12. Now, did we find the gh of x? We did. The gh of x was found earlier on in part 3. So always check your part 3s earlier. You could do it again, but it's not. So it's pretty much saying when is 1 over x squared minus 4, that's from part 3, equal 1 over 12. And pretty much by cross multiplying, we end up with 12 is equal to x squared minus 4. And you bring everything to one side. X squared, well, we don't need to actually, because we'll leave the x squared on this side. X squared is equal to, comes across at 16. So x is equal to square root 16. X is plus or minus 4. Again, it's not anything in terms of length, so it can be plus or minus 4. So there's a good few examples to take down. So there'll be a bit of work in this. I'll give you a few questions, and if there's anything you're unsure, please ask.